Hello, today I want to present you the results of the research called VAD in speech coder based on Wavelet transform done by Oleksandr, Tymchenko, Bohdana, Havrysh, Orest, Khamula, and Bohdan Kovalskyi. Today we will cover the overview in the basic requirements of the VAD systems, determination of the main parameter of the telephone signal for the operation on the VAD system, the proposed mechanisms, schemas, and much more. So the use of VAD provides a possibility to pre-process the speech signal before transferring it to the encoder. In the first approximation, the following types of signal fragments can be selected. So vocalized, non-vocalized, transitional, and paused. When the transmission speech in digital form, that is in the form of a sequence of numbers, each type of signal with the same duration and the same quality requires a different number of bits for encoding and transmission. The simplest example of the VAD mechanism is illustrated in the figure 1, which you can see on the slide. The speech signal enters the input of the comparison device in which the amplitude is measured and compared with the given threshold value at some selected time intervals. There is a VAD method based on the power level calculated in each speech segment. This algorithm is more complicated in comparison to the previous one, as it requires the calculation of the power of the running fragment and the determination of the ratio. The formula you can see on the slide also. So if the value is less than the specified threshold, then as in the previous case, this will determine the need to discard the packet. The third solution is when the GSM standard adopts the VAD scheme with the processing in the frequency domain. Work is based on the difference between the spectral characteristics of speech and noise. Background noise is assumed to be stationary over a relatively long period of time, and its spectrum slowly changes over time. VAD determines the spectral deviation of the input action from the background noise spectrum. The VAD detector must be sensitive and fast to avoid loss of word onsets when transitioning from pause to an active speech fragment, and at the same time, the VAD detector must not be triggered by the background noise. The telephone conversation between two consumers is usually accompanied by the large number of emotional pauses, and taking into account the delays expertized by SpeechPact in VoIP network, pauses and added to natural speech to wait for an answer. For this study, it can be assumed that the distribution of instantaneous value of speech signals corresponds to the exponential law. The details of the formula you can see on the slide. Also, the influence of pauses is taken into account using the activity of coefficient K of the signal source. It is equal to the ratio of the time during which the signal level at its output exceeds the set threshold value to the total conversion time. It was extremely experimentally established that the quality of the reception of the TEF signal is still acceptable. The average interference power, therefore the required immunity of the telephone signal should be calculated as on the formula you see the first on this slide. But the dynamic range of the TE signal calculated as the ratio of the maximum power to the average power of the permissible interference is equal to the second formula, you can see. And when we evaluating the potential information volume, it is necessary to take into account the activity coefficient of the signal source. So in the VAD structure, the noise level and the output of the encoder is equalized, and its threshold is set, adapting the encoder in relation to the value of the input speech signal. Analogs to this solution, noise equalization can be replaced by maintaining the input signal level within certain limits while simultaneously fixing the noise level. That is, such a scheme becomes adaptive to the signal level. The implementation of such principle is simple, both in analog and digital form. Its structure corresponds to the circuit with automatic gain control, which means it has the ability to adapt almost instantly to the level of the input signal. So the scheme of evaluating the quality of the speech signal that we talked before is now displayed on your screens. The VAD performance study also can be observed here. It includes of input signal, output signal, and output signal from the different segment power. The MCE of the output signal is shown here in three different versions. First one is at the level of 1/128, the second of 1/16, and the third one is VD at the general file level. And the study of the work of the VD compression ratio is displayed here. And in the last slide, you can see the comparison of VD method by compression ratio by level and by power. So the proposed VAD operation algorithm is highly efficient, provides a sufficiently high compression ratio. When evaluating the quality of VAD work according to the SKD criterion and when listening to processed speech samples, it is possible to indicate the maximum value of rejected quantization levels and the value of the adaptive power threshold at which the number of zeros segments practically does not affect the quality of the restored speech signal. Therefore, during the conducted research, slightly deviation of the quality of speech signal reproduction are observed when discarding up to 8 quantization levels of 128, or when a power threshold of 0.3% of the maximum signal level in the segment is set. Accordingly, the achieved compression ratio is 19.35 and 15.6. So thank you for your attention.